Welcome back, math students. I hope that everyone had a nice Thanksgiving. We are going to talk today about congruent figures. We're starting our new chapter. You should have your note packet out. You should have your worksheets ready also. You won't need your really hurt your eyes pink kind of worksheet out yet, but we will be using that starting tomorrow. Today we're talking about congruent figures. Congruent is really what we mean when we say that they have the same size and the same shape. They should match exactly. So for instance, on the first two triangles, these are the same. If I would take this reddish triangle and kind of rotate it so that this side would kind of flop down onto the horizontal, you would be able to slide these and make sure that they were exactly the same. But they look like they're the same size, same shape. We're not going to make it look like they match, but they don't really match. If they look like they match, they match. If you look at the second pair of triangles, they are clearly not congruent. They're the same shape, yes, but they are not the same size. In fact, since these are the same shape but not the same size, we're going to call those similar figures, and we're going to be talking about that later in this chapter. When I have congruent figures, we've got these different parts that are corresponding, parts that match. So if they're the same size and same shape, they're going to be called congruent. And then those congruent triangles have all of these different parts. And you can see they're kind of color-coded and matched. The colors on the sides are helpful, but we're also going to be using things called tick marks to show things that are the same. So for instance, I've got that AB matches DF. You can see they're in the same position. They are the same length. They're the same color on here, but also if I was marking them, I would do something like that. The matching marks on there show that they match. For BC, I would maybe do like a double. And then for the last one, not a big surprise here, we could do a triple. Or there's other things you can do. Sometimes we do something that looks like a V. Whatever matches from one picture to the next is how we could show that they are going to be the parts that match. They're corresponding. We will be talking more later, but they're also going to be congruent. The angles also match. So they have this mark in, I'm going to change colors here. Angle B has that single mark on there. Those are corresponding angles. They match. Also, angle A, I'm going to do a double here, matches with angle D. And then angle C, we can do a triple, or sometimes there's other shapes that we use for showing that they match. But that's some of the markings that we might be doing as we go through this chapter. Now, the fact that they're congruent means that the corresponding parts are also congruent, but for right now, I'm not even asking which parts are congruent. I'm just worried about the matching parts. So I don't think that we need to necessarily list all four pairs of sides and all four pairs of angles. However, I'm going to say I expect you to be very careful when you're naming this. This is based on what I know you're going to need when you go to geometry. And I want to make sure that this is going to match what you're expected to do there. So if I want to talk about side, let's say AB, this side right here, that matches with JK. When I name that, I want to say the same order for both of them. I would want to say that AB, and I even like that segment mark above it, and JK, just kidding, are the corresponding parts. Now, please make sure that you call it AB and JK, not AB and KJ. I would want to go in the same order. If I'm going from A to B, I would want to do the same thing here. So then any other pair, because I'm only asking you to write down two pairs in this example, two pairs of corresponding angles. I started with the sides. Oops, sorry. So if I would, let me do this one in kind of a reverse order instead of going from right to or left to right. Let me go with AD. So if I use AD, that segment would be matched up with JM. Okay. When I'm talking about corresponding angles, for right now, one letter is good enough. There are times when that won't be good enough, but right now it is. So clearly I've used angle A and angle J in both of these pairs. So let's use that. I could use angle A and angle J. Forgot my angle mark. Does everybody see that little angle mark that I put in front? That's the way that we write angle in geometry. Again, the segment marks above the segment names help also. So let's pick another angle pair. So we said that A and J matched. B matches up with K. So angle B and angle K. This one is a little tricky because it's not quite clear how to get the first shape and the second shape entirely lined up. We'd have two options. Either we could, let's keep the first one exactly the way it is. The second one, we could rotate so that the point S would come down to the bottom, kind of like we have right here, because clearly this angle and this angle match. That's one option, if we would rotate it. The other option that we could have is, what if I would just flip it? If I would take this shape right here and just flip it so that this side would go down there. Either way would work. It doesn't have a clear answer on this one because there's symmetry in the shape. If it wasn't so symmetrical, it'd be much easier to just say, oh, it has to rotate or it has to reflect or flip. Because we can see that angle M and angle S are matching, let's just pick that as one of our first angles, angle M and angle S. Then, as long as I've got it written this way, we're going to just pretend like the second shape is just going to flip so that the top goes down to the bottom. So then I could pick other angles that would match up. If I would flip that over, then angle R, we're going to go with right here, would match up with angle N. If I had rotated it, it'd be a different answer for that part. So again, we're going to stick with the reflections. Let's get our side pairs. So I would say that JK, this side right here, seems pretty clear that it's going to match up with this one. So I would say that JK, that segment, is going to match up with QP. And then if I would want to pick one other one. Now I like when I've got stuff like M and N that both have angle marks, I can see that that segment that's between them, MN, would have to match up with the one that has the two angle marks in the other shape. And because I'm starting with M that has the single marked angle to the N, which has the double marked angle, if I go MN, then the one that I'd have to do over here, same order, single mark for S, double mark for R, so I'm going to go with SR. Here are all the tick marks that I've already kind of explained to you. When we have congruent figures, congruent shapes, then the corresponding parts, the corresponding sides and angles are also going to be congruent. Here's the sign that we use for congruent, right here. It looks like an equal sign with a squiggly on top. The squiggly means similar, means it's the same shape. The equal sign means it's the same size. So it's the same size and shape, all in one little symbol right there. And it is different than just an equal sign. So when we're talking about shapes, we want to use that congruent symbol. When I have these three different squares, I want to find which square is congruent to square A. So we've got square A right here. Clearly these are both squares because they say they're squares, even though C might be a little off. If it's kind of at an angle like that, it's harder to tell. But the side lengths are 8. Square B has side lengths that are 9. That's not the same size. Square C, side lengths that are 8. So are the angles congruent? Yes, because they're squares. They have to have right angles. Are the sides congruent? Yeah, they are. So it's got to be C for our answer on this one. Okay, given this information, can you decide if the two shapes, the two figures, are congruent? So I've got angles that are marked. I know that this angle with the double mark is the same as this angle with the double mark. These two are the same, and so are these two. Those are called isosceles triangles, for those of you that remember those names. And I've got, again, because it's isosceles, these are both 5, and so are these. So those sides match up. This is a 6, matches up with that 6. Are these congruent? Yes, because all of the corresponding parts are congruent. We're going to use a lot of abbreviations in this chapter. We use CORR for corresponding. We're going to use a lot more in the next chapter. And we're going to use that congruent symbol as much as possible. Okay, just looking at this, I would hope that you'd be able to tell. They are clearly not congruent. They both look like rectangles. We've got opposite angles that are right angles, but they're not the same size. So are they congruent? No. You wouldn't even have to say anything about the shape. You could just say they're not the same size. So the corresponding side lengths don't match. Okay, I have these two trapezoids. So we've got ABCD and JKLM. I want you to notice the naming on here also. They have the names over here. ABCD, JKLM, that matters. That first letter A matches with the first letter J. Those are corresponding parts. When we're naming this, that matters. B is in the second position, and so is K. Those parts match. So I could be marking things like this one matches this. B, second letter, matches this second letter. Here's the third one, C, and that matches this third one. Once we get to 3, it gets kind of hard to get 4 in there without being kind of obnoxious. So sometimes you'll do something like this, some other marking, as long as they match. So these two are congruent. If I want to know how long side JM is, look at this. JM, first and last letter, would match up with the first and last letter there. And you can see it from the picture as well. So if AD is 10 feet, sorry, that's kind of a messy feet, but that's going to be 10 feet for JM. And the perimeter of JKLM would be exactly the same as the perimeter of ABCD because they are congruent. They're the same size and shape. So if I can find the perimeter of ABCD, it's going to be the same for the other shape. So when I add this, I would do 8 and 8 is 16, 16 and 6 is 22, and 10 is going to be 32 feet. Last slide now. These are two desks, like computer desks, kind of like the one that's in our math classroom, and they're identical. So that means they are congruent. They didn't give a list of all the names. However, if I am asking you questions like, how long is side NP, which is right here, that would have to match up with this corresponding part right there, which is 3 feet. And side AB is congruent to side CD. So right here's AB. That's congruent to CD. Well, if those parts are congruent, then that means that these parts, the corresponding parts, are also congruent. So now that I have all that stuff marked, can we figure out how long side AB is? Well, AB is congruent to CD. CD is congruent to LM, which is 6 feet. So that means that AB also has to be 6 feet. Okay, that's the end of the lesson. You have your worksheet in your packet. It's the first one, it's for the 30th of November. Good luck with that. If you have any questions on it, please make sure that you ask.